Breaking the wall of oceanic carbon dioxide removal. Lorena Neira Ramírez, Falling Walls Lab, Peru.
We've all heard of climate change. There is scientific consensus it is the greatest challenge of our century. Because of this, the industry, and really all of us, are being challenged on a daily basis to transition into carbon neutrality. However, becoming carbon neutral will not only mean to reduce our reliance on fossil fuels, but it will also mean to compensate for all the CO2 we've been putting into the atmosphere since the Industrial Revolution. That is, as you must be imagining, a huge, large number. Every year, we emit around 10 gigatons of CO2 to the atmosphere. This is a carbon imbalance that has been building up to 300 gigatons after we started anthropogenic emissions. So if we really want to compensate for a three-figure number of CO2 emissions, we need an immensely powerful system. As a climate scientist and a marine biologist, I've come to learn forests, contrary to the popular belief, are not the lung of the Earth. The ocean is. In fact, the ocean is also our biggest, most scalable carbon sink available for humankind. So the question is, how do we enhance the biggest, most scalable carbon sink on Earth to capture carbon? We are using materials engineering to manufacture artificial carbon units inspired in coralline algae. These carbon units are innovation that we can flat on the ocean bottom, changing the carbonic chemistry of any seafloor of choice to capture carbon up to 4 times more efficiently than any other wild unintervened ecosystem could on its own. The concept is pretty simple. The more area we cover, the more carbon we capture. And as we are introducing nature into the design, our carbon units are able to transform themselves into extensive areas of coralline algae beds. These beds can then serve as a sediment substrate for coral reef larvae and other marine species. This is exactly how we're going to heal ocean biodiversity and breaking the wall of oceanic CO2 removal. Thank you.